What's going on, my students? What's going on? Actually, I have no idea why I went into Italian voice right there, like a spicy meatball, like Mario. And we're back. I just got back. We're saying my name for something. No. I was just saying we have Victoria in the classroom. Welcome, Victoria. Here's what the assignment that I have set up for you guys. I think it's going to be an awesome one. I've been putting the finishing touches on it. That's why I haven't posted it yet. But it's going to be called Tracker Parabolas. And I'm going to have you track a few things because you know what the thing that's really cool is we've been seeing a bunch of parabolas inside of this motion stuff. So this week's all about tracker, and we're learning how to track things, and we're learning how to deduce information from that. So far you've been able to calculate out the speed at which something moves at. Remember we were doing the dune buggy and it goes, and then we would calculate out how fast that object is moving, right? We were able to calculate how fast that thing was moving by looking at the slope of the line. Slope of the line. But we found that actually most things in nature don't move with a constant velocity. Most things in nature speed up or slow down, and when they speed up and slow down, when we look at the position of that, they form what we call parabolas, little curvy things, and that's kind of what we've been talking about this week. So these parabolas kind of govern a whole lot of information for us too. We can find out the velocity that they're moving at any given time. We can find out the what gravity is just by looking at things, just by observing things, analyzing it. We can figure out what gravity is. I think that's amazing, like friggin' amazing. But I don't like to say the friggin' word. It's really amazing. So we'll call it ramazing. Anyway, it's ramazing. It's really amazing that we can figure out gravity from that. So what we're going to do today is I'm going to basically do your assignment for you, kind of, not really. I'm just going to show you all of the steps that you would need to take, and then you get to go and analyze it yourself, and you tell me what you guys need to do. So essentially, I'm making this video as kind of a tutorial for the assignment. And then what I'm going to do is include this as this video as a hyperlink in the assignment. And that way, if you guys get confused in the assignment, you guys can all go back and figure out like how I did things. Cool? So anyway, let's get this party started. Here is your assignment. Although I'm not going to give you the link to it now. I just want you to watch your computer screen. Cool? And what I'm going to do is I'm going to download each of these things. So I just go to here. And I want to download it. So I'm going to download a picture of this dude. He looks mean. He's like, Alright, so that's one of them. Good. Alright, so I got that one. Now I'm going to download this one, Shoot and Drop. Shoot and Drop. And that's the one where this guy is shooting a ball horizontally and shooting and dropping it at the same time. So I'm going to download that. And then I'm going to download this one. So I'm just kind of preparing myself for all of the ones I want to download. Cool? So, part A, step 3. Download everything. I'm doing it now, see? It's working on it right now. Actually, wait, why did this thing have 2 shoot and drops? Huh. Oops. Maybe I provided the wrong hyperlink. Let me just kind of fix that right now. Oops, I'm sorry. All right, let's see. That was the ball toss out. I want that one. Okay. There's the right hyperlink. Let's get that one. See, this is why I'm fixing it right in front of you guys, because I'm just making sure. Because I don't want another shoot. There we go. Ball toss out. I hope that works. Video says it's not processed yet. Let's see if that worked. Alright, cool. I guess it did. Alright, so we confused with anything? I had to fix the assignment for us because I accidentally put 2 shoot and drop links, but No, it's pretty good. All right. So what we're going to do is we are going to analyze each of these videos, and I will show you how to do that. In fact, that's what I'm doing. So first thing you open up is Tracker. Now, for some of you, does anyone have a problem loading Tracker? Does anyone have a problem doing that yet? I know Victoria says Tracker just hates my computer. All right, Victoria, what I'm going to do for you is I'm going to see if I can provide you the data itself. And it's not because I like you more or anything. It's just because, I mean, I want you to be able to do some of this stuff. Anyway, what I'm going to do is, all I'm going to do is I'm going to drag and drop each of these things into here. So, okay, I dragged and dropped this dude into here. I'm going to do a new tab. I'm going to drag and drop the shoot and drop in there. And I'll drag and drop the other one in there. So here's shoot and drop. Okay, wait 1 second. Shoot and drop's taking a little bit. When all else fails, use the school computer. Nolan had problems too. Yeah, I don't know. I don't know. Anyway, hey, here's what the plan is today, okay? The plan is this week we're going to use Tracker to analyze motion. And we're going to understand why it applies to parabolas and all of that kind of stuff. Next week, what we're going to do is I'm going to, take the people who didn't really do well for the HSA, the ones who didn't pass, who got really close but didn't pass, actually everyone who didn't pass, and I want them to go through the HSA. We're going to review everything we possibly can to try to get you ready for that, because you're going to be taking that on May 5th, I believe. The second thing we're going to do next week is we are going to build our ping pong ball launchers. That is my plan. So we're going to do two things. We're going to review for HSA, build ping pong ball launchers. Yeah, I am using the plan. I'm just kind of giving you an idea of what I'm coming up with. I haven't finished building the assignments yet, so I haven't put them on the plan. I'm just kind of giving you my, this is what I'm thinking about doing. Got it? All right. Now, after we build our ping pong ball launchers, what I want to do is I want to combine those two abilities and use Tracker to track our ping pong ball launcher so we get really accurate pictures as to what the velocity this thing shoots the ball out at. I think that's really cool. And then after that, we can use that to basically calculate like what angle and what speed we should use in order to sniper other people and other things. I would recommend highly not snipering people with the ping pong ball launcher, unless of course it's inside of our final project that I think would be really fun, where we all go inside of a gym and we wear these really cool safety goggles and we shoot ping pong balls at each other as in a war. And I just think that would be awesome. It'd be fun. It'd be fun for me. I think it would be. All right. Anyway, dude, shoot and drop's taking a long time to stuff. All right. You're talking about the HSA, and yes, you only have 2 attempts on passing the HSA, but I think you've only done the science once. The first time they gave the HSA, they didn't offer science, so that didn't count as an attempt. The second time they offered it, they offered the science, and so that was your first attempt. And then now the third time they're offering the science. So yes, you only have 2 attempts, but you only did the science once so far. Does that make sense? Dude, and what's the deal with shoot and drop? It's taking a long time. Let me just kind of redo it. See if it reloads. Hopefully it does. Wait, what's confusing? What's so confusing about it? I'm just telling you that, like, it's coming up on May 5th. So this past. Yeah, the first one that you guys took back in November was only reading and math. The second one you took in like February was science and whatever you didn't pass from the first one. And then the third time we're offering it in May it's only science and whatever you didn't pass. Well, I guess if you took a second try already, then you're all done. So that's what the deal with that is. All right, and I gotta upload all of these things. So I'm gonna just go to this new tab right here. I'm gonna upload this stuff. All right. So any confusion on how to upload the videos, by the way, all you do is you just drag them straight into the tracker, and you'll be good. We cool? All right. Good. The videos downloaded onto your computer, right? Yeah, exactly. I downloaded them first, so I just clicked on each of these links and then I downloaded them. And they appear down here, and then you can find where exactly you downloaded them, but I just drag them straight from this bar into the tracker and it uploads it straight to there. Cool? All right. So what I'm going to do is I'm going to use Tracker on all of these things, and I'm going to do it pretty quickly because you've done this many times before. Let's show you what's going on. So I'm going to have my coordinate system. You guys got it? Now this coordinate system, I'm going to call the ball, when the ball goes to the ground, that will be 0. So let me just get to the end over here and see where the ball hits the ground. That's going to be my 0. So I'm going to put my coordinate system right here. Are we cool? And then for the calibration, what would you guys use for calibration? I'm just curious to know. Look at the video. Is there anything good we can use for calibration? Oh, he's got a meter stick attached to the wall. I think that's a little cheater, but that's cool. That's actually not cheating. That's very smart. All right, I'll go with that. So that would be a 1 meter. So I'm going to deal in meters here. I don't want to deal in centimeters. So I'm just going to put 1 there. And then what I'm going to do is I'm going to track the ball. And all I got to do is create a new track. Point mass. And we'll track it. And I'll just hold on Shift and I'll click the ball. See where he drops it. And then what I'm going to do is, let me zoom in. And it's hard, because after a while, if your camera's not like super strong, then if your camera's not super HD, or even if it is HD, it still gets blurry when it's moving. So do your best to track it. Do your best to try to get the middle of the ball or a distinct point on the ball. Sometimes I use like the edge of the ball or the bottom edge of the ball. Yeah, that's good. All right, cool. Let's see what the Y data looks like. Oh, that's perfect. So what I did is I clicked on here, I left clicked on here, and I just changed it from looking at the X version to the Y version. And what do we see here, my friends? Say it with me. Parabola. Awesome. It's half of a parabola because it's really just the top half of an upside down parabola. All right. Then what we'll do is we'll copy and paste that data straight up into here. Okay, and then I'm going to delete this extra data down here. Now, what I'm going to do for you guys, is I'm going to give you this Excel file. So you guys can, all you guys got to do is copy and paste your thing. Jordan says Tracker doesn't show you that graph. Okay, sometimes Jordan, what's going on is Tracker will look like this. Does your graph look like this? Does your thing look like this? Oh, it doesn't show you the small graph? It doesn't show you this one right here? The top right? Okay, all right. What I've noticed is sometimes it looks like that. All you gotta do is, in order to see that graph, you just pull it down this way. And then sometimes they have this one all the way up, and so you don't see that, you know, that small graph. So you can pull that data down there, and then it will have this extra window. And you can change what it is you wanted to see. Like you wanted to see a table or plot or whatever. But essentially, the thing that we're copying, Sophia, is we're copying the data. So the X and Y data. So we have time over here, and we have X and Y, and we're good. So I just Control C, Control V, it's straight into there, and it gives me the data. Are we cool? All right. Now, what I've been doing is, the X data is kind of uninteresting to us. You know what I mean? Like in this case, the X data is kind of uninteresting because it's a horizontal line. In fact, not only is it a horizontal line, it's a horizontal line at 0. Why is that? Because the ball drops vertically only, it doesn't drop in the Y or the X direction. So essentially, that's kind of useless information. And then C equals initial height. All right. So I'll tell you what we'll do is we'll try making a graph. So we'll delete this one right here. Delete the chart. And we'll try making another graph. So when I make a chart, I just kind of highlight what I want to graph, and then I'll put in a chart, and I'll do a scatter plot. That's what I like doing. Perfect. All right. Now I want a third graph, and I'm going to call this Y guess. Huh. I guess it didn't pick up any of that information. All right. Now, it's got to be a parabola, so let's put in the standard form of a parabola. Do you guys know what I mean? Standard form quadratic. It's where we have that thing that looks like a... There we go. A times x squared plus b times x plus c. And that's what the standard form of our thing. You've seen this before, right? A times x squared plus b times x plus c, equals blah, blah, blah. In fact, you need it in the standard form for the quadratic equation, and this is kind of what... So instead of using x, though, I'm going to use t. So this is going to be my a value, whatever it is here. So the number here, number here, number here. For now, let's just put in 0, 0, 0. We'll change those in just a second. But here's what I'm going to do. And you don't necessarily need to do this. I'm going to have it all set up for you. I'm just showing you how I built this. So I'm going to tell the thing, use cell F1 and multiply that by A2 squared. So what that is it's A, it's A times x squared. In this case, the x is the t because that's the horizontal graph. Or that's the horizontal axis, is my time. Do you guys understand what I'm doing here? And then I also need the plus b times x, so that would be $F$2 times A2. And then I need this plus c, so it's $F$3. Now, watch this. Right now, A is 0, B is 0, and C is 0. So I need to start putting in some numbers. What was the initial height of the ball to begin with? About 2 feet. Well, not necessarily 2 feet. Remember, we're measuring things in meters, right? We told the computer that here, look at the graph. See, that's about 1 meter. So the computer's saying that it's about, let's see, about 2.1 meters. In fact, actually right there. So that's my initial height. So let's put in that, 2.113. Perfect. All right. Now, let's put in some numbers for gravity and let's see. Give me some numbers. Give me some guesses. 1. All right. Oh, we got a curve. We're looking good, but the problem is it's the wrong way. All right. 3. No, it's looking even worse. All right, -1. Oh, we're getting better. Let's try -3. Fine. Let's get better. How close can we get it? -4. Close. Can we go? -3.5. Not worse. All right, -4.5. Awesome. What about -5? Does it do better? Oh, that looks great. Although I think it's too much. Let's try -4.9. How's that? -4.8. You think that's the best one? -4.8? Alright, cool. Awesome. Well, that's the name of the game. That's all we're going to be doing pretty much today. We're just going to be doing this to the whole graph. All we're going to do is we're going to change this value so that we can figure out what this is, because I'm telling you that this is the measurement of gravity. Gravity is negative, has something to do with -4.8 or -4.9. Okay? It has something to do with that number. I'm not telling you it's exactly that number, it just has something to do with it. Alright, let's try this one. So, we're going to go back to tracker. What's going on, Raven? Can you hear our voice and see our face and all of that kind of stuff? Alright, now, we watched a video and it's this dude, he sets it up. Most of the video is him setting it up. That's a little boring. There we go. So he's putting the ball at the end and the ball over there. And you guys seen this video, right? You guys remember when I showed it to you the other day? Yeah. Well, it's actually not laggy. I'm just kind of stepping the video back by small steps. Alright, so the crazy thing is he shoots the ball out and he drops the ball at the same exact time. And they hit the floor at the same time. And that was mind-blowing to us. But then we thought about it. We really thought about it and we said, wait a second. Gravity only acts in the vertical direction. So even though the ball's being shot out, it's only being pulled down by gravity, so therefore it kind of does make sense that they hit at the same exact time. Interesting. See, we're using our analysis to figure out what the way the world works. They're at the same height. Yes, if they were at different heights, then it would be a different story altogether. But anyway, let's try doing an analysis of this. So apparently my video starts at about 1999. Let me show you guys how to start the video at a certain spot. I click over here and it says clip settings, and I wanted to start at 1999. Because I don't want the computer to think that all that setup was anything I want to analyze. And one of the things that they did in this video, if you watch the video in regular speed, they do it in slow motion. So I'm going to change that to 60 frames per second. Because they actually shoot it in slow motion, so that you can see exactly when they hit. So that's how I changed the frame rate. So really they're playing it in halftime to make sure that you guys can see it. Alright, then let's start analyzing this. I've got my coordinate system set up. Where would you say, what kind of calibration, how would you do the calibration on this thing? What are your thoughts? I'll give you guys a minute to think about it. What's in this video that I know the length of? You know, like calibration, like when we use the meter stick over here, we knew exactly how big a meter is. What calibration? He didn't put a meter stick in this thing. Darn guy. I can use the thing in the middle of the ball. Sure, I could, but the problem is I don't know what the length of that is. They didn't tell me in the video. The height of the balls, sure. Also, he didn't tell me how high that he set this thing up at. I didn't get that piece of information. I just saw this thing from the video. Maybe we can guess this guy's shoe size and then say, okay, well, here. But then that's still a guess, though. You want to see what I would do? How I would calibrate this video? What I mean by calibration is there's got to be something in this video that I know the height of. Either the height or the distance or the length. I'll give you a hint. You guys mentioned something about the balls. Let's look at it. See those balls? I'm told that they are billiard balls. If they are indeed billiard balls, or pool table balls, then they have a very specified diameter. That diameter being 1 or 2¼ inch diameter. So, since I don't know the height of or the length of anything else in this video, I don't know how tall he is, I don't know how big his ring is or his arm is, I don't know how big that table is, I'm going to use the size of this billiard ball because I know that those are probably the same. It's not like they use enlarged billiard balls or extra small billiard balls in this video. And apparently it's 1.25 inches, but I wanted to use meters, so I'm going to go, or actually not two, it's 2.25 inches to meters. And the computer tells me that that's 0.05715 meters. So I can just tell the computer that, see this distance from here to here? That's 0.05715. Excuse me, I'm sorry. Why would you measure the ball and not the distance the ball touches the ground? What I'm doing is I'm trying to tell the computer, Raven, a standard distance that is in here so that the computer can scale everything correctly. The problem is he didn't tell me how high above the ground he lifted the thing up. So I don't know the exact number of that. So I wouldn't be able to tell you, that use that as my calibration. Over here, this guy conveniently put a meter stick on the wall. Nice of him. Thank you. I appreciate that. But over here, this dude didn't. He didn't put no meter stick. He didn't put no ruler. It would be really nice if he did. If he had a meter stick over here, I would use that. Because the bigger your calibration thing is, the more accurate you can get. The size of a billiard ball is pretty, it's pretty tough to, get it super accurate. In fact, I'm a little bit off. It looks to me like that's the bottom, and that's about the top. It's still but it's still the same diameter of the pool ball. But I'm just using that as my calibration. Now, since I didn't have a ruler, I can use that. All right, so what I'm going to do now is I'm going to track it. And we'll track it. Point mass. By the way, I'm pretty much doing your homework for you, so all you got to do is just do the same exact thing. And I'm going to track this piece right here. Do you know what I'm going to do? I'm going to see if I can get this. Hopefully, it will find this. You know what? I'm going to do it this way. I would like for you to track for me this big white ball. Actually, you know what? Okay, wait. I want to get there. I'm going to get right there. Okay. All right, let's try that. Wait, oops. I think I accidentally messed it up. Hold on. Let me do another track. Okay. I want to get right at this corner. Hopefully that works. All right, so I want you to search. Looks pretty good. Looks pretty good. Looks like we're able to find that piece right there. Let me zoom down just a little bit. All right. I think it's going to mess up right as we get to the ground because the background changes a little bit. Yeah, see, the computer says, I can't find this picture over here because in this square, it can't find anything that looks like that. So that's why it kind of stopped and says, I don't understand what you're doing. And then I'll say, okay, fine, close. I'm going to press shift. And I'm just going to manually do it. But I don't really need to worry about it too much because I have my data. Let's take a look at it. What is it? Say it with me. A parabola, half of a parabola, which is pretty cool. All right, let's copy and paste that data straight over to here. Actually, you know what? We'll just do it like this. I'll duplicate this. I'll call this one shoot. Oops. T. So there's my data this time. There's my X data. There's my Y data. And my guess. Now this is the old guess, so I don't want to use any of that information. Let's go with 0, 0. So what I'm going to do is we're going to try out new data. Now what, my friends, would you say this new data is? What is the initial height of the ball? $1.2? No. It's right there. It's 1.083294,288. Of course, I didn't need that accurate. I mean, come on. What is the initial velocity of the ball in the vertical direction? Remember, this is the ball that wasn't moving, and then it just dropped. So the initial velocity was 0. That's why I put 0. What about the gravity? Take a guess of it for me. What do you guys think? What should we try? What number? We want to make this yellow graph look like that red graph. -2. Let's try that. Oh, it didn't work. -3. Are you guys really going to not believe me when I... -5. -5 was a little bit too much. This time I'm going to go with -4.5. How about -4.3? -4.2. I would say that's our best right there. -4.2. What we're trying to do is we're trying to figure out what the value of gravity is. And when we did, okay, we'll call this shoot and drop dropped. When we did it on the ball just being dropped, we got -4.9 was a pretty good guess. When we're doing it on this ball being dropped, we got -4.2 is a pretty good guess. But the fact that it's close to -4, between -4 and -5, is actually a really good sign. I would say that this one is a little bit less accurate because the calibration that we used was a little bit off. You see what I mean? Why is gravity negative? Well, yeah, fine, riddle me that. Why is gravity negative then? Because it's going down. Because gravity pulls down. That makes sense. It moves in the negative direction, therefore it's negative. Oh yeah. See, I love the realization that we can get here. I love how like the world that we live in is so nicely explained. It's amazing. Now let's try a new track. I did a track of a drop ball. In fact, I can rename that to be dropped ball. And I'll call the next one shot ball. It's not mask A. This will be shot ball. Is it shoot ball or shot ball? Let's change the color on it. Let's make it a blue track. Alright, now let's track this thing. Now, I'll be honest with you, this one's going to be a little bit harder to track because his darn shirt is so crazy, and then most of the other background is black. So what I'm going to do is I'm just going to track this one. I'm going to track the front bottom of his thing right there. And once it gets past his shirt, I'm going to let the computer do an auto track on that. There we go. Alright, now I'm going to press Control-Shift. This hopefully will get more accurate. I want you to try to find this picture in a square that big. For the most part, I know that the thing is going to be on that side. So let me just show you what I'm doing. I'm going to search it. Search, auto search it for me. Hopefully that works. Hopefully it works. It's going to go good. It's going to mess up right when it gets here. Yep. Alright, so let me just kind of do it manually. I gotta tell the computer this because the computer's like, what's going on? I don't even know how to track that thing. So I'm gonna do it manually for you. There we go. Alright. So we have this data right here. So let me show you what these data points look like, because it actually looks pretty cool. Let's play it. And there I tracked this thing going straight, and I tracked this thing going down. So I tracked the drop ball, and I tracked the shot ball, and we're pretty good. Alright. Now, let's look at the Y data and see what that is. What do we got here? What shape is that thing? It's half a parabola. That's amazing. Let's copy and paste this data. So we'll call this one shoot and drop. Not copy of shoot and drop. This will be shoot and drop shot. Alright, so let me copy and paste that data straight in there. And look what I got this time. That's very interesting. Alright. What's the difference between this graph and this graph? The only difference, I would argue, that the only difference between those two graphs, in fact, if you want to look at it at the same scale, you can look at it like this. How can I tell it to, okay, minimum 0, maximum 1.2. We'll do the same thing here. Minimum 0, maximum 1.2. Alright. So look at this graph, and look at this graph. Oh, I need the y-axis the same, so let's make this. Okay, let me fix this real quick. Alright. What's the difference between this graph right here and this graph right here? The blue line. It's the blue line, the slope of it. It went from horizontal to now some kind of angle. And what does that blue line remind you of? Didn't you do an assignment very similar? No, not the half a parabola. The dune buggy. That blue line looks like the dune buggy, doesn't it? That darn dune buggy. That dune buggy that was moving constantly in the horizontal direction, doesn't it? That darn dune buggy. Well, here's what I'm saying, dude. Like, check this out. This is actually really mind-blowing. I think this is really cool. That dune buggy was moving at a constant velocity in the horizontal direction, but it wasn't moving in the y direction, right? Whereas this ball that's being shot out, think of a ball. Pretend that you're a baseball player and you have a baseball and you throw it straight horizontally. Don't do it now because you'll hit your computer. But if you think about a ball being thrown straight horizontally, okay? As it travels, it's going to go down like this. It's going to go forward. Now, by looking at this graph, we can kind of say that, it looks to me like it's going at a constant velocity horizontally, but in the vertical direction, it's moving as if it were just like a drop ball. You guys see that? Do you see that? I'm talking about in the horizontal direction, it's moving at a constant velocity because it looks just like the data from the dune buggy. You see what I mean? So could I calculate the speed at which that ball was being shot out horizontally? Yeah. And how would I do that? Distance over time, you find the slope. That's exactly what I'm saying. Sophia, you're absolutely right. It would be the same as how we found the speed at which the dune buggy was moving at. You find the slope of this blue line, and that tells you how fast you shot this thing out horizontally. Exactly. Now, how fast was it moving vertically? Well, it wasn't moving vertically. Its velocity initial vertically was 0. We can kind of see that because our graph already matches the thing pretty nicely. We didn't have to change these numbers, did we? See, our guess one looks just like what our data was. We didn't have to change numbers at all. I suppose that our numbers should be a little bit different. Like, we should technically take this number and put it here, but it's not really going to change much. All right, so Pia's saying, so the red line shows how the speed changes as it moves, and the blue lines how it moved in a specific direction. No. The red line shows it how it moved in the y direction. The blue line shows it how it moved in the x direction. That's all of that data is. That's all it is. Okay? This isn't magic. Let me show you what it's doing. All it's doing is this. All right, you guys. Time 0. Okay, so now what I'm going to do is at time 0, I'm going to measure how far it is from the x direction. So measure the distance from here to here. And I'm also going to measure how far it is in the y direction. So measure the distance from here to here. And then it moves. And then it measures it again. And then it moves. And then it measures it again. And again, and again, and again. And that's all it's doing. Now what is the yellow line? See, the blue line is the x direction, that's the data. The red line is the y direction, that's the data. This yellow line right here is me trying to figure out what that parabola is. Because I told you that it was a parabola, but I didn't tell you exactly how Like, I didn't prove to you that it was a parabola. I just told you, hey, doesn't that look like a parabola? But it could be some other curve that looks kind of like a parabola and not be exactly a parabola. So what we're doing is we're trying to fit, we're guessing a parabola that looks like the red one. We want to change these numbers, so negative 4.1. We want to change the numbers so that they'll look like a parabola. And here's what I want to show you, because I don't think that I'm done. I'm not done with this assignment, and I'm sorry. I just want you to start working on some of these assignments, like start taking the data down and processing that. But you don't necessarily need to finish it because I didn't finish explaining it to you. It's a long project. This is the assignment that I'm giving you right here. I'm actually doing it for you. So I'm just giving it to you this week. It's going to be due sometime next week. So don't freak out. But anyway, here's what I want to look at. The ball drop is negative 4.9. The shoot and drop the dropped one is negative 4.9 or 4.2. This one is negative 4.3. I calculated out this ball toss. It's this other video that you haven't tracked yet, and it looks like this. And all it is just tossing a ping pong ball. Actually, I don't think that's a ping pong ball. It's kind of more of a white marble thing. I calculated that one out to be negative 4.9 as well. Now, I told you that that number has something to do with gravity. And let's look up gravity. No, not the movie Gravity. Acceleration of gravity in meters per second. Because I think this will be really interesting. Hopefully it will be something like 4.9. That's the acceleration of gravity in meters per second. Squared, that is. So did we get it right? What did we calculate it out to be? Negative 4.9. Negative 4.9. Negative 4.2. Negative 4.2. Did we get it right? The answer is 9.80665. No, we didn't. But remember, I didn't say that that number was exactly gravity. I said it was related to gravity. And let me show you how. Newton's equations. It's not because I'm using Wikipedia, by the way. Oh, this is the hard version. Let's go with there we go. Let's look at this equation. That looks a lot like our thing, where we have at squared, we have some other number times t, and we have some other number after at the end. Notice what's in front of that thing. I want to do this and I'm done with my class. I just want to explain this to you because I want to blow your mind. Notice what's in front of that thing. What is that? Tell it to me. It's a 0.5, right? So the number that I've been guessing is this number altogether. So technically, if I wanted to have my number match gravity exactly, then what I would do is I would say, okay, well, what is negative 4.9 times 2? Because what I've been measuring is half of what I should be. So let's try negative 4.9 times 2. And what do I get? I'm pausing because I'm usually see when I'm teaching face-to-face class, I'm thinking to myself, everyone's like, what? Whoa! And they're like, oh, no way! And I can't see you do that. I really wish I could, but I feel like you are. All I did was I just kind of was like, let's try this, and I multiplied by 2, and then I just sat there and I imagine everyone's going, what? That's amazing! Look at what we did. Here, let me show you what. All right, remember I looked it up. The acceleration of gravity in meters per second squared is 9.8. We calculated it out to be 4.9, but I was telling you that that number that we're measuring is related to gravity. It's not exactly it. You have to double it. So when we double it, it became negative 9.8. Please tell me that's cool. Please tell me that. Then what about the others? What are you talking about the others? Which one are you talking about? You're talking about the 4.2 and the 4.3? Yeah, all right. Here's my explanation for that. Here's what I would say for that. The fact of the matter is we didn't have a nice calibration stick to use. So I had to use some kind of small thing. And the smaller your calibration stick is, the more inaccurate it is. The fact that we got really close to negative 4.9 is actually a really good sign. But you also have to keep in mind that this science is not completely super. I mean, it is. I'm not saying this science is inaccurate. It's the there could be some errors in measuring it, and there's going to be some discrepancies. But essentially, around the world, you're going to measure negative 9.8. So I mean, the fact of the matter is, we got really cool. We got off by a decimal. Like, that's not even that bad. Galileo calculated it out to be like negative 10 instead of negative 9.8. So he would have guessed that this number over here is negative 5. And we're talking about Galileo, like one of the smartest dudes ever. Newton didn't even know that it was negative 9.8. He thought it was negative 10 as well. Which half of that would be 5, of course, right? So we did better than Newton. We did better than Sir Isaac Newton and Galileo of Galilee. Actually, I don't know what Galileo's first name was. Maybe that was his first name. Maybe of Galilee was his last name. I don't know. Maybe he was just like a one-name kind of person. We did better than Newton. Does that not blow your mind? Is that not kind of cool? All right, so here's what your project is. And I got 1 minute to explain it, and I'm over by 10 minutes. I apologize already. I am a bad, mean person, but I'll just let you know what I'm doing with this thing. Let me show you what the last video is, because I think it's pretty cool. Here, throw a basketball. All right, so what I did was I dropped a basketball. I just took a basketball and I dropped it. I know it's super laggy. And then I threw it. Like that. What you're going to do in this assignment is essentially, the boom mic. Actually, do you guys know Draven? He's this guy with this really big hair. That was his hair. I know. It's weird. He's got big hair. And I asked him to help me be the video. It wasn't a boom mic. It was, Anyway, I dropped the ball, and I want you guys to measure the acceleration of gravity from that. And then I threw the ball like that, and from that, knowing the acceleration of gravity, I want you to measure how fast I threw the ball at just by looking at the video. And by the way, yes, I already posted it. It's not directly in the course. It's in the assignment. Oh, I didn't post it yet. Never mind. All right. So that is what your instructions are. I know that this is going to be a long project. It's going to be a tough one. It's going to be a fun one. And I pretty much did it for you. You just have to do what I did. And I will post this YouTube video up so you can see what I did. And we are good. You guys good? Happy? Sad? Come on, you guys. Clap along if you guys feel like a room without a roof. How are we going to be doing these assignments? Emailing them to you? Yes. No, you're going to put them in Dropboxes. I'm going to post this assignment up right now, but it's not completely done. I haven't finished writing out the instructions because I just made it this morning. And this is brand new stuff. Like, I'm making this up as I go along. I'm making up your homework as I go along. Can you talk about how you're going to be? You're going to be doing these. Oh, wait. Victoria, you're going to do something a little different because yours doesn't work. Okay. What I will do is I will give you all of the data. And your job is going to be to process it. How's that? No, Victoria, I think that we're going to have a lot of fun building the ping pong ball launcher, and that one, there will be no technical issues because you just build a ping pong ball launcher. If you want to get started on that, you'll be good. All right? And if anyone else, Nolan, I know that your tracker doesn't always work, so I'm going to let you do that as well. Not Nolan, Nicholas. Nicholas? Whose didn't work? I don't know. All right. Anyway, I got to go. Class is over. Talk to you later. See you next week.